Hello, this is Mr. Buss, and of course in this video series we'll be going through the 8C ecology calculations practice, assuming that you've already tried these on your own. So of course you can watch the video and kind of play and pause as you work these problems out, but that's the intention, is that you've already given these some thought and worked on them a little bit, and just using this video to check your answers or to get help where needed. So feel free to fast forward to the section that you need, or skip to the, I'm going to probably put these in a playlist. Skip to the video in the playlist that is going over the questions that you need help with. Okay, so go ahead and get started. The concept of diversity is, of course, a concept that we're used to in general use of the word. And, with biology, it's not too different. The biology definition of diversity, how many different species are there would be one way to look at it. And so, between these two containers here, of course, we have, an honor today, day I'm making this video, the Vikings. Of course, the NFL draft is occurring. So here's a little bit of a Vikings purple and yellow here. So, in this one, we have three varieties, or we'll call them species. So we have the purple, the yellow, and the white, three species. In this one, we have four species. So, of course, you would say that's more diverse, 4 species versus 3. But so that would be true. And then there's a second thought to diversity. It's not just the number of species, it's how evenly distributed they are. So here, not only are there only 3 species as opposed to 4, but you notice that more than half of them are made up of the purple species, right, the variety. So these are not as evenly distributed, okay? And here, it's a little more even. We either have 2 or 3 of each of the species. So more evenly distributed and more number of species. So those are the two definitions. But we can mathematically calculate that. So let's go ahead and do that. Let's mathematically calculate the diversity index. So we're going to take 1 minus the sum of each of the little n, and the numerator is each of the species. So like 6 purple, for instance. And big N is the total population, so like 6 purple over 10 total. You square that, and then you add it to all the other ones. And so I'll show what I mean by that. So for purple, so this is, the equation is 1 minus, I'm going to bracket it, the sum of purple, so I'll do purple color for that. 6 over 10 squared plus, I'll do yellow. Yellow is 3 over 10 squared plus the white, which I'll have to use a gray for that, 1 over 10 squared. And the brackets there. And then, so that's the setup. It's the diversity index is, 1 minus the sum of each of the individual species divided by the population total, square that, add them up. So I'll get my calculator here. Here it is. I'm just going to, rather than, it's tricky to put all the brackets and parentheses in the calculator, so, and I'm just going to go ahead and go, 0.6 square that. So 0.6 squared is 0.36. 0.3, because 3 over 10 is 0.3. 0.3 squared is 0.09. And 0.1, because 1 over 10 is 0.1. 0.1 squared is 0.01. So now we're going to add all those up. 0.1 plus 0.09. Oops. 0.1 plus 0.09. Oh my gosh, my calculator. Plus 0.36. Sorry about the time it took me to punch those numbers in. That's 0.46. Is that the answer? No, because it's 1 minus 0.46. So the answer is 0.54. Okay, so what? What does that mean? Well, this isn't written down on the species diversity or the diversity index, but the idea is if the number is closer to 1 it is more diverse. And if the number is closer to 0, it is less diverse. Okay, so 0.54, kind of in the middle there. So basically, this is a comparative here. We're going to compare these two. Oops. Try this again. I'm just going to kind of shrink that so I got more room to work here. So there's the first one that we did, and now we'll work with the second container there. So looks like it's all 2s and 3s. So like 2 pinks, 2 oranges, 3 blues, 3 greens. So I'm just going to go 1 minus 2 over 10 squared plus 2 over 10 squared, because that'd be like, for the 2 over 10 would be like pink, and 2 over 10 would be orange. And we have 3 over 10, that'd be like the blue. And 3 over 10 for the green. So we're going to do all of those and take 1 minus that. So 0.2 squared is 0.04, so 1 minus 0.04 plus 0.04 plus 0.3 squared is 0.09. So add those up, do 1 minus all those. And that's going to be 1 minus 0.26, which equals 0.74. So that's the answer. That's the species diversity index for that one. And so comparing these two, 0.74, so 0.74 would be the species diversity index for this one, and 0.54 would be the species diversity index for that one. And of course, this one is more diverse. We knew that intuitively because there were more different species and also more evenly distributed, and 0.74 is closer to 1 than 0.54, so we've mathematically shown that as well.